Recording.
Hi, so in this video, we are going to see that what is the expression, what is the equation of magnetic field due to the current in a straight line. So basically, if we see this diagram, I have already drawn this diagram. So Mn is actually the straight line wire, and there is a current I which is moving through this particular wire, and you can see point P. So point P is at distance D from the wire Mn. And so I'm interested to know that what can be the final expression of the magnetic field on this point P due to the wire Mn, straight wire Mn, which is located at distance D. So that is what I'll be discussing in this video. So I think I have told all the basics here. I'll try to spotlight and I'll try to say each and everything which I have drawn in this particular diagram. So there is M and N are the random points, two random points of the infinitely long straight wire. Then there's point P, which is some random point located at distance D from the straight wire MN. And there is some current I, which is flowing through this particular straight wire MN. And so and then there is a current element, a small element of the wire which is located by DL, and this particular current element, it is making an angle theta with R. It is making angle theta with the resultant vector R. So yes, and then if we see the endpoints, then with the endpoints, if we see randomly, then there are two different angles made from, we are taking projection from point P to the ends of the wires, and the angles are theta 1 and theta 2. So now the magnetic field at point P due to the wire, sorry, I have missed out, due to the wire Mn is, yes, due to Mn wire at point P is, due to the element is, okay, I messed it up, sorry. Yeah, so magnetic field, I should remove this due at least, yeah. So magnetic field at point P due to the element is dB is equals to mu 0 upon 4 pi into IDL sine theta upon R square. This basically comes from Biot-Savart's law, and I have already made a video on that, so you can check that video. And let us call this as equation number 1, and we will be using this equation further in our video. So now if we see the diagram, we will do some basic trigonometry. So if we see this diagram, then we can find out, based on this angle theta, we can find out that, that L is equals to minus D. L is equals to minus D cot theta. Oops, sorry, it's cot theta. So yes. So now I will differentiate this dl with respect to d theta. So that's going to be minus d upon d theta into d cot theta, sorry, d cot theta. So that is going to be dl is equals to minus d cosec square theta. Cosec square theta d theta is what I will get. Now, also we can see from this diagram, if we want to find out cosec theta, so I'll just write down here randomly. So if we want to find out cosec theta, but before that, let's find out sine theta, So if we see sine theta here, then we should be writing, so this is our theta. So with respect to that, we are supposed to write sine theta. So that's going to be opposite side upon hypotenuse. So here the opposite side is d. So it is d upon r. So if I want to write cosec theta, so that is r upon d. So R is going to be d cosec theta actually, right? D cosec theta. So we will be writing this R is equals to d cosec theta in our equations here. So let's write down. So R is equals to, also R is equals to d cosec theta, sorry, yeah, d cosec theta. So that is what we have. So we can so now let us call this as equation 2 and let us call this as equation 3, and we will put equation 2 and 3 in equation 1. So what is equation 1 with us? We will rewrite it. So it is dB is equals to mu 0 upon 4 pi. dB is equals to mu 0 upon 4 pi into dl sine theta is what we have. dl sine theta upon r square. So mu 0 upon mu 0 I will be as it is, and the value of dl is we already have equation 2, right? So we will be writing that. So dl is it is minus, here we will be writing this value. So d cosec square theta. So we substituted this dl. Now sine theta remains as it is, and r square. So here r squared is going to be d square cosec square theta. So I'll be writing that d square cosec square theta, and so cosec square theta gets cancelled, and so we are just remaining with mu 0 I upon 4 pi. That too, it is sine theta. Okay, so we are remaining with this particular value, and here minus should not be there. It will just be plus, because differentiation of cot theta is going to be minus cosec square theta, so minus minus gets cancelled. So we are remaining with just this part, that is dB is equals to mu 0 upon mu 0 I upon 4 pi into sine theta. So I will integrate this. So this can be integrated like integration dB is equals to mu 0 I upon 4 pi d into sine theta d theta. So that is b is equals to mu 0 I is constant, and it is like it's okay if we don't integrate it. So sine theta d theta. So now this integration is from theta 1 to theta 2. Okay, like these angles, they play a very important role in expressing the magnetic field at point P, you know. So mu 0 I upon 4 pi d. So that is going to be minus cos theta from theta 1 to theta 2. This is definite integration. So we will be writing mu 0 I upon 4 pi d. And this is going to be, first we always put the upper limit, plus we put the lower limit, that is minus minus is going to be plus. So the equation that we get is going to be b is equals to mu 0 I upon 4 pi d into cos theta 1 minus cos theta 2. So this is the final equation that we have for the magnetic field at point P due to some straight wire. So now suppose we want to know that what is the field on the perpendicular bisector. So say for example field on a perpendicular perpendicular bisector. So suppose we want to know that. So now what is the perpendicular bisector? So perpendicular bisector meaning that um, exactly at this point. I'll just spotlight and we'll try to know where exactly. So this seems to be a perpendicular bisector to me because it divides this particular wire into equal parts. So we want to know that what is the magnetic field over there. So we will be knowing that, we will be writing that. So the point P is on its perpendicular bisector. Okay, so point P is on the perpendicular bisector of ML, right? So here, so we can write down that suppose suppose we have Mn, suppose Mn is equal to A. So then that will make OM and ON as A upon 2. Will make them as A upon 2. So here we have, here this OM and ON. So this would be like A upon 2 if at all we are considering entire Mn to be A. So here we have, so if we substitute cos theta, like if we want to get cos theta out of this, cos theta 1 and cos theta 2 out of two triangles, then we can write cos theta 1 is equals to A upon 2 upon under root A square upon 4 plus D square. So that would be A upon A square plus 4D square. And then similarly, if we want to write cos theta 2, then that is going to be minus A upon A square plus 4D square. So we can put these values. So I will just continue with the number of equation that we were in. Yes, we can call this to be equation number 4. This is say equation 4. And let's say this is equation 5. This is equation 5 and this is equation 6. So we put equation 5 and equation 6 in equation 4. So we will put them in equation 4. So that will give us B is equals to mu 0 I upon 4 pi D into A upon under root A square plus 4D square plus A upon under root A square plus 4D square. So that will make it as mu 0 I upon 4 pi D plus 2A upon under root A square plus 4D square. So if I cancel this, then I'm going to get mu 0 IA upon 2 pi D upon A square plus 4D square. This is what I'll get. So let us call this to be, what was our equation number? Yes, this is our equation number 7. So now what if I want to know that what is the field due to the long straight wire? So in this diagram, whatever wire we are considering, that is MN wire. So it is just a chunk of long infinitely straight wire. So we just want to consider, the long straight wire. So what will happen? So if we consider long straight wire, then we need to make changes with these angles. That is theta 1 and theta 2. So because this P, the projection, the random projection that P will make with the ends of the wire will be very much different if we consider a long straight wire. Okay, so that is why. Okay, so I'll just write down in the fresh whiteboard. So field due to the long straight wire field due to the long straight wire. Okay, so that is so here it is. So for the long straight wire, we can see that theta 1 here is going to be 0, and theta 2 is going to be pi, because yes, because theta 2 is going to be pi. Um, Sorry. Yeah. So that is 180 degree. It will make the angle pi with with p. It will make the angle pi because it's going to be a very long wire, right? So it's really long. So almost it will make the angle pi. That is, it will almost, the angle of projection will almost be parallel to the point P. So it will be 180 degree. Okay. That is theta 2 is equal to pi. So we can write that theta 1 is equals to 0 and theta 2 is equal to pi. So if I put it in equation, put these values in equation. So which equation I should put it in? This is the general equation. So I'll be putting these values in this general equation. So it is B is equals to, I'll be putting it as B is equals to mu 0 I upon 4 pi into, so cos theta 1 is going to be cos 0 minus cos theta 2 is going to be cos pi. So B is equals to mu 0 I upon 4 pi. So this is 1 plus 1. So mu 0 I upon 4 pi into 2. So that would make B is equals to mu 0 I upon 2 pi D. Oops, we have forgotten D in this equation. So we need to write D. Let's see if we have written that in general equation. Yes, we have written that in general equation. So yes. So due to infinitely straight wire, so this is what it is for infinitely straight wire, like for a long straight wire field due to the long straight wire. I'll just conclude in this whiteboard, and field on a perpendicular bisector. So B is equals to, we wrote it as mu 0 IA upon 2 pi D under root A square plus 4D square. This is what we wrote. So this is the field due to, okay, I'll make it more organized. Yeah. So yes. So this is the field due to the field on a perpendicular bisector. Field on a perpendicular bisector. Of course, with respect to the figure that we made, sorry, bisector. Yeah, and so the general equation that we got for the field is B is equals to mu 0 I upon 4 pi D into cos theta 1 minus cos theta 2. So this is the general equation that we have got. So what is this exactly? We should be writing. This is the field at point P due to field at point P due to a wire MM. So I hope this video was helpful to you. These equations are important as it can help us to solve several numericals from several different reference books. So I hope this video was helpful. I'll see you in the next video. Bye bye.